All right, so before I begin, thank you so much for dedicating your Friday night to spending some time with us. I very much want to appreciate your time, so I want to go ahead and jump right in if that's okay with you all. Can everyone see my screen okay?
Yes, it's perfect.
Excellent. Okay, so this talk is all about becoming a data scientist, not just the technical skills they might have to learn, but sort of the educational journey that a lot of people go through in order to become one. So I've been a teacher for the past 2 years now, and I've been really lucky to meet people on all steps of their learning journey to becoming a data scientist. And hopefully by meeting all these people, I can kind of tell you what I've seen work well and what I've seen maybe not work so well. So this is my personal data science journey. As mentioned before, I started off as a hardware reliability engineer. But at the same time, I went to school in various places because, how do I describe it? So I've always was interested in artificial intelligence. My goal growing up was I was really very much into video games, and I was always fascinated by how artificial intelligence works in video games. Like, how do you make a computer smart enough to be able to be a human? So that's kind of been my guiding light over these past few years. And every time I decide to undergo some sort of educational course, or every time I try to switch my job, I try to make it one step closer to finally reaching that goal of making video game AI. So that's how I finally ended up being an AI teacher. And I think I'm pretty happy here. I'm hopefully going to be here the rest of my life. And it's been a lot of fun, and hopefully I can share this journey with you. So before I get into deep, I want to talk about the Deep Learning Institute at NVIDIA. So if I was pessimist, I might want to be thinking, why wouldn't NVIDIA hire an AI teacher? What's their end goal here? And I'm very lucky in that I'm not a salesperson. It's not my job to try and get you to buy NVIDIA products. It's really my job to try and help you be successful as a data scientist. And there's a few reasons for that. A, what's the point of making GPUs if no one knows how to use them? But B, it might seem like NVIDIA is a GPU company. It might seem like that's our top goal, but actually our top goal is empowerment. Like, we get so much joy out of seeing people create cool things with our technology. So as you go on your journey, we want to hear about it. We want to hear about the cool things that you do. That's what drives us to be able to do what we do. So before I go into the different types of educational resources out there, I kind of want to go over the different types of skills that are needed to be a data scientist, because where you can figure out, if you're able to figure out where you're strong, and if you're able to figure out where you're weak, it'll make it so much easier for you to figure out, okay, this is what I need to do in order to become stronger with my weaknesses, or this is where I can play up my strengths to have an advantage. So some of you might have seen this slide before, this Venn diagram, and it's kind of considered that there's these 3 key areas that make up what is a data scientist. So in this area here, we have this mythical data science unicorn. And why are they so mythical and powerful? Well, they're able to take mathematics and computer science, and they're able to solve challenging business problems. So they're very flexible people. And if you're this person that's a master of everything there, chances are you're able to come up with profitable ideas pretty quickly. So let's do some bad news, good news. The bad news is that each one of these areas is easily going to take years to master. Like, I spent 4 years in my undergrad mastering mathematics, and I feel like there's still so much more in that field that I can learn. And that's definitely true of the other fields too. Like, there's way more I can learn in computer science, and there's way more that I can learn to kind of master my business sense. So the top 2, let's go over mathematics, computer science. Those are things that you might be able to easily pick up in school. But at the bottom there, I have business sense. And that's going to be something that, sure, you can go to school for it, but a lot of people will tell you that's where your experience at work is really going to come into play. So I said this was going to be some bad news, good news. The good news is because it requires so many skills to become a data science unicorn, there are tons of different paths that you can take in order to get to the center of that circle. So here I've laid out a few different types of roles based on this Venn diagram here. So if you're just pure mathematics, maybe you'll end up being a statistician. If you're just pure computer science, you might be a computer scientist. If all you focus on is business, then you might be a program manager. And then if you look at the in-between spots, if you combine mathematics with good business sense, then you might end up being a business analyst. If you combine statistics with computer science, you might end up being a machine learning engineer. And if you combine business with computer science, you might end up being a software engineer. And then if you get all those together, bam, right in the center, we have data science. So what I think is really awesome about this is, let's say you're someone that's fresh out of your undergrad in college. Chances are you're going to be somewhere on the top of this Venn diagram. You might be in the top left in statistics, and you might be in the top right in computer science. Now you're just at the start of your learning journey, right? And we can start using a combination of both education and work experience to try and make our way towards the center of this diagram. And what I think is really cool is, sure, you can start off as technical, but I've met a lot of people who started off as program managers, or maybe even something in the arts, who started at the bottom of the circle, this like business sense or domain knowledge area. And they're able to learn the technical skills even after college to be able to become a data scientist. So on this diagram at the top, we have mathematics and computer science. Those are things that you might be able to master a little bit better with typical education. Certainly some of it is going to be on-the-job work experience, but kind of some core concepts like calculus. Like, yeah, there might be some jobs out there where you can learn on the job, but it's probably just going to be way easier to take some sort of class to be able to learn and master calculus. Whereas on the other hand, business sense, sure, there are some college classes out there that try to capture those soft skills that are so hard to quantify, right? Like being able to sell your skills correctly, not over and undervaluing what you can do, or being able to connect different departments together, connecting people. Or what I think is like probably the most critical is being flexible, being able to understand, okay, here I might need a spreadsheet versus building a massive database. Like, what's the simplest solution to these complex problems? Those things is going to take a little bit more, like your real life practical experience will help a lot there. So one question that I get a lot as a data science teacher is, okay, where do I go for my education? Do I want to take a university class, or do I want to go online and take like a self-paced 8-hour workshop? And a lot of that's going to depend on you and where your strengths and weaknesses lie. So the better that you understand yourself, the easier it's going to be to figure out which type of education is best for you. So I like to think of it as a scale, kind of like a microscope. So a university class, it's kind of like that course adjustment on a microscope. It's going to be able to give you these huge, big steps pretty quickly. Whereas the workshops, those online classes, they're a little bit more of like the fine adjustment on a microscope. It's going to be able to help you exactly pinpoint where you want to be. And the advantages of a university course is, even though it takes many weeks or even months, they're able to go into concepts in much greater depth than an 8-hour class can do. So at NVIDIA DLI, we focus a lot on these workshops, sort of these 8-hour experiences. And we do our best to be able to fit in as much content as we can within those 8 hours. But lots of physics only work in such ways, right? Like the university course is going to be able to cram so much more information in those months than we can do in an 8-hour workshop. But on the other hand, with these workshops, because they're shorter, we kind of have an advantage at DLI compared to a university class that we're much more flexible in the classes that we're able to develop. So our classes tend to be a little bit closer to industry. I mean, I'm literally able to go and talk to an engineer at NVIDIA and figure out what they're doing today and build a class on top of that. So these university classes, they take a long time to make, whereas these workshop classes, yeah, they can take a while to make too, but because their production time is so much shorter, we're able to be a little bit more maneuverable, if that makes any sense. And of course, those are the only two options, right? So like I mentioned before, I worked and I studied at a work-study university where half the year I would work and the other half the year I would study. And that was like such a powerful combo, right? because going to work, I was able to realize, okay, these are the classes that are actually going to be worth my time and money, right? Like university courses aren't cheap in a lot of cases. So I definitely recommend that kind of approach, is to take a look at your work or the world, kind of figure out what is needed, and then figure out from there what you think would be the best educational classes for you. So a lot of people reach out to me on LinkedIn. They say, Danielle, you've seen a lot of people on your data science journey. What's the best thing for me? And by the way, you're more than welcome to do the same. Feel free to reach out to me on LinkedIn and ask me what's best for you. But if you want like the quick breakdown of what I'm going to do, I'm going to go look at your LinkedIn profile, and I'm going to look at various things here. So the first thing I'm going to realize is, can you code? Like, that's such a basic skill for data science. It's kind of like our ABCs, right? If you don't know how to code, I'll recommend some sort of online self-paced course like Codecademy. If you haven't checked it out before, I have the link here. But that's how a lot of engineers and data scientists I know have learned how to code. It's this online interactive program where you just practice the skill directly. So that's a great way to learn Python. So if you know how to code, I'm going to try and probe you a little bit and figure out, is data science really what you want to do? Because it is a lifelong journey to become one. And if you're not fully committed, it's going to be hard to get anywhere fast, right? So if you're not sure what you want to do, I would recommend taking some sort of online introductory workshop, some sort of couple-hour or one-day class, just to get your hands dirty and figure out if this is the career path that's right for you. So if you're fully decided that that's what you want to do, then I'll start taking a look at your education. So first I'll see, do you have some sort of undergraduate degree? And if you don't, that's totally fine. I would encourage you to go ahead and try to get your undergrad degree in some sort of technical area, such as math or computer science. Now, university degree is going to depend a lot on a lot of people, right? Because it's a huge investment in time and money. And some people, they just don't learn well in a traditional academic setting. Their brains just work in a different way, and that's totally fine. Like, the world is full of diverse people. There are diverse ways to learn. So I'm going to go over in a little bit what you can do if college is not the right path for you. But for now, if college is the right path for you, I definitely recommend trying to get your undergrad in math or computer science. So if you already have your undergrad degree, next step is to look at your master's, right? And if you have your master's, definitely try and get a job in a data science field. Now, a lot of people have a hard time straight out of school jumping straight into that center of that circle, right? It's very difficult to do. So when I say data science field, I mean trying to land somewhere on this Venn diagram. And then hopefully over the course of your career, if you have your eyes on the prize, eventually you're going to make your way into the center of the circle. A lot of people ask me whether it's worth it to get a PhD or not. And again, that's like a very personal question. Because at least in the United States, I understand it could work a little bit different in India. That's going to be a multi-year investment on a single problem. So if that single problem is something that you're really personally passionate about, like, by all means, go for it. But if you're kind of unwavering of like, what do I want to spend that time on? Maybe PhD isn't the right thing for you to do. You can do so much with just work experience and online learning resources. All right, so let's talk about those that college isn't quite the best fit for. And I've been lucky enough to meet a handful of people who have been really excellent data scientists, very respected, who don't have a lick of college experience whatsoever. And the people that are able to find success in this way, they're extremely self-driven. So one person that I met that became a data scientist, they created their own web development company straight out of high school. They knew that they just loved making websites, and they would ask members of their community, and that's how they got paid, was that for small businesses within their community, they made websites. And the people that go down this path, what they tend to do is they'll find their own educational material. So they'll go online and they'll do these self-paced workshops, or they'll attend boot camps. Or I've known someone who like literally would just go online and look at college curriculum, see what textbooks were being used, and they bought the textbook on their own and they went through it at their own time. And that just takes incredible willpower. So if you're someone that has that type of passion, like by all means, go for it. You can do it. The trick here is that there's got to be some sort of way to measure your skill. And that's why universities love colleges, or not universities. That's why companies love colleges, because it's easy to be able to look at your degree and say, okay, you're probably proficient in these areas. So if you don't have that degree, there's other ways that you can go proving your skill in these areas. So if you build a successful business, that's one way to prove your skill. If you win a competition like Kaggle, like by all means, go for it. You can, there's some people that just make these breakthrough research papers on their own. I remember in college, there was such a hubbub because a homeless person was able to write this breakthrough research paper in the field of mathematics. And my teachers love pointing out that, hey, never judge someone by their appearance, because you never know that person that you're walking by on the street is actually some sort of mathematical genius. So definitely, if you have the drive, there are ways for you to be able to prove yourself. So a lot of what I do as a data science teacher, I'm going to be able to teach you the technical skills to make this career transition, but B, I'm also very much like a workout instructor. And a lot of my job is just trying to motivate you to keep your eyes on the prize. Because sure, I might be able to teach you things, give you like a workout regimen, but at the end of the day, the change has to come from you. And that's what makes it so rewarding as a teacher, is seeing that change come from you and seeing you finally succeed in your goals. So I definitely want to hear about it if and when you succeed in your goal. It's such a reward. Anyway, so some tricks that you can do to help stay motivated is, one is find someone that's essentially an accountability partner. So like in workouts, that's the person that's telling you that, yes, you can do those 10 extra push-ups. Yes, you can do all those sit-ups. You can do it. Totally works the same way when it comes to your technical education. Like, especially if they're going to go through a class with you, or it's someone at work that's in the same department as you. It makes it so much more sweet during those frustrating times where, say, you're taking a class and it just doesn't seem like it's technically possible. They'll be there to be able to push you, say, yes, you can do it, you can get through the night. And like when you're up late and you can both have pizza together, and it kind of makes it kind of fun, even though you're both frustrated. But at the end of the day, you're able to get through this challenge together. And when you're able to help them succeed and they can help you succeed, it's just such a good feeling for both of you. So the other piece of advice I can give you is one that I got from a college teacher while I was working on my thesis, which is, chances are you're going to be spending a lot of your personal time on this. And if you're going to be spending your personal time on it, you should do it for you, right? So try and find a goal that inspires you, and that's what's going to keep you on track over the course of these many years. So for me, I've always wanted to teach artificial intelligence to play video games as well as humans can. But because AI is so pervasive, it's in so many different fields, you can kind of dream big here, right? So maybe you want to teach an artificial intelligence to sing, or maybe you want to create a robot dog that can go fetch the paper for you. So you can think big or even small here. Maybe you just have a short-term goal of, hey, I want to learn how convolutional neural networks work. Anything that you can do that keeps you driven, hold on to that. All right, so now that we kind of have a strong understanding of what skills are useful, I'd like to talk a little bit more about the NVIDIA Deep Learning Institute and kind of what resources we have available to help you on your learning journey. So we try and make courses in all sorts of different fields. We do things large and small. So if you're just getting out into data science, I think I mentioned before, you're not sure this is the right course or path for you, we have some fundamental content so that you can immediately see what deep learning is all about and decide what's right for you. Then we also have things on the other end of the spectrum too, like, okay, you have a good understanding of how neural networks work. What are some different ways that you can apply it? So we have courses in learning how to make an autonomous vehicle, or how to use artificial intelligence to find, I recently did one with MRIs of the heart to be able to see if there's any malignant cells in it. Of course, we're NVIDIA, so our focus is on GPUs. And I love working with them because they're just so fast. So if that's interesting, if you ever feel like a GPU is something that's critical to your workflow, come to us, because we're gonna be able to help you straight from like the horse's mouth, right? Like we work with the people that work on these GPUs for you. So we work on a wide variety of content, not just in terms of technically, but also that microscope I was telling you about. So from us directly, we make a lot of self-paced online courses, but we also do things like work with universities to help modernize their curriculum. So we have online classes if that's kind of your style. They're $30 for a 2 to 4 hour course, and they're $90 for the full day. A lot of that money is just going to paying for the GPU space. So if you want to go mine Bitcoin on it, like you've paid for it, I guess, have fun. But we think usually it's a better use of your resources to hopefully use the educational material that comes with it. A lot of people work better in instructor self-paced, or not instructor self-paced, but instructor-led workshops. And this is kind of your cliche educational setting where you have a bunch of people in a classroom and you have a teacher sitting at the front of it. So because of the pandemic, we've moved that operation online. And so if your organization's interested and you have like a bunch of people in your organization that are interested in a particular subject, you can kind of reach out to NVIDIA and we will do an online educational workshop with you. And then if your organization is a little bit more interested in training a large variety of people, you can reach out to us and we'll kind of help build a curriculum for your team. So this is a kind of a cliche instructor-led workshop that we would build. So we'll have, usually there's about 3 labs, and each one of those will spin up a GPU for an hour and a half or 2. And we'll walk through some sort of technical concept. And then there'll be some lunch breaks in between. So this is really great because for these instructor-led workshops, they're really good for people that kind of need motivation, A, from an instructor, and B, also from their peers, right? Like there's something special about being with a group of people all that have the same goal in mind, and you can ask questions. So if you're someone that works best in that type of environment, this might be the way to go. Now, if you're not part of an organization that can sponsor this type of event, that's fine. NVIDIA has our big conferences, we call them GTC. And if you go and attend these conferences, we will offer these to the public. And then the other thing that we do is on self-paced online training. And this is much more varied in the type of content that we can do. It'd be anywhere between a quick 2-hour, this is how you do something walkthrough, versus a more in-depth 8-hour course. And we do our best to make our material as self-explanatory as possible. So hopefully, what am I trying to say here? So if it's some sort of introductory content, like we're recently releasing a course for Deep Learning 101 that's going to talk about convolutional neural networks and how they work. That would probably be an 8-hour class that talks a little bit more about the math and how to use it. And if you want to go that traditional university route, we have work with all sorts of different partners. If you're still in school and your educational institution would be interested in working with NVIDIA, like by all means reach out. Education is something that's kind of shared, right? Like once it's out there, there's no point in like hiding it and keeping it private. So here at NVIDIA, we believe sharing is caring, and we definitely want to work with you if you have a cool idea. Oh yeah, and you can become a university ambassador too. So if you're a teacher or maybe a teacher assistant, you can get certified with NVIDIA to be able to teach your classes for no cost. So just one quick recap. If we go back to our microphone analogy, we have the coarse adjustment versus the fine adjustment. NVIDIA does things at all ends of the spectrum. So there's really no point in me saying this is the one way to go, right? Definitely do whatever is best for you. So if you need that large step, if traditional college is the right way for you, there's a university out there that has some sort of class like high performance computing that uses a GPU, chances are we're already working with them. If you're someone that already has a lot of work experience, you already have your undergrad or your master's degree, and it's just not quite worth it for you to go to college, that's totally fine too. We have these workshops to be able to support you to help get you towards your goals. And then we also have things in between too. So we work with Udacity to help make some nano degrees. So like for me personally, there was one point where I did use one of these nano degrees in my educational journey when I was making the transition from a hardware reliability engineer into software. I went and got the full stack Udacity nano degree. And that's what kind of gave me leverage to say, look, I can code. You should hire me to be a web developer. So this is these nano degrees or boot camps. They're a pretty powerful tool for people that want to switch careers from one to another. And as mentioned before, if you're interested in taking the DLI class, definitely join us at GTC. We'd love to see you there. So one more thing I was hoping to go over, if we have the time, is I wanted to talk about kind of this, in the United States, we call it catch-22, which is kind of this requirement that's impossible to satisfy. So you might have, what am I trying to say here? There have been a few times where there was a role that I was particularly interested in, but in that particular role, they were only looking for people that had experience in production systems. And it's kind of tricky because if you don't have experience in these production systems and the industry wants people with it, like how are you supposed to get your foot in the door? So I'm not going to be able to 100% solve that problem. I think there's a lot of psychology at play there, but I can help get a little bit closer to being able to satisfy that requirement. And like, by the way, pro tip, if there's a role that you're particularly interested in, and you've noticed that it's been on the job board for a long time, like maybe a few months, and you don't just quite meet the requirements for it, like totally reach out, because especially if you've been taking classes that are meant to help you get towards that job role, the worst that the hiring manager is going to be able to say is no, right? And that's not that terrible, just to hear that you can't do it. The best that they're going to happen to say is, yes, I can see that you're pretty close, let's bring you on board. But there's also kind of this interesting third path that I've taken, and I've seen a lot of other people taken, which is the hiring manager will say, okay, I see you're not quite qualified yet, but I can see that you're on the right trajectory, and let me help you make a transition plan to be able to get to this role. And that's like the best situation, because those hiring managers end up being excellent workplace managers too. You can tell right off the bat that they're supportive of education. So by all means, if you're taking your free time to work on your technical skills, either through some sort of online class or some sort of personal project, like show that off. People love seeing that self-driven personality. Anyway, that's kind of an aside. I want to get back to the problem at hand, which is how do we kind of simulate getting production experience without being an actual production engineer? So in a real world setting with artificial intelligence, there's lots of things to consider when we deploy our trained machine learning models. Like A, we have the model ourselves, but B, there's also these pipelines that we have to consider. Like usually our data is in this giant SQL database, or maybe it's stored in a bunch of CSV files somewhere. And they're in the cloud, so we got to be able to pull it from one machine and put it on another machine so that we can get the training. And thankfully, so there are a bunch of these different roles that support all of this too. So if we go back to our Venn diagram before, that captures a lot of the roles here. So there's data scientists and researchers. One that I think is like super popular because you can't do anything unless your data is clean is a data engineer. And to me, that's like where all the money is really, because if you're a master of the data, you understand how to transform it, how to move it. Like that's what powers the rest of these roles here. So NVIDIA has a service called the NVIDIA GPU Cloud. That's meant to kind of help people, whether you're learning to do production services or you're already someone in a production environment, that needs to take advantage of some tools. So one of those tools is going to be Docker. If you've never heard of Docker before, it's very similar to a virtual machine. The difference between a Docker container and a virtual machine is that a virtual machine has simulated hardware that's running underneath the hood, whereas a container is also kind of like a simulated computer, but it's going to use the hardware and operating system of its host machine. And the reason why this is becoming more and more popular in production environments is you can go to your local machine and create this Docker container. And once you're satisfied with how it works, then you can take it, go to your server farm, go to your cloud, go to your AWS, Google, or Microsoft Azure, and be able to deploy it in a production environment. And it's great that that's what the trajectory that the industry is going through, because you can go ahead and learn how to master Docker locally on your local machine. And once you feel comfortable with it, you can go to these different cloud providers and learn from them how to deploy it. Each of them have their own classes, similar to NVIDIA does, on how to employ Docker environments. So that's one way that you can kind of get that production experience that a lot of people are looking for. By the way, NGC Cloud or NVIDIA GPU Cloud is not just about Docker containers. They have other things too, like we have pre-trained machine learning models. That's another trajectory that production machine learning is going in, is why not take advantage of other people's hard work? Like it takes a lot of time to be able to develop a machine learning model that can detect images or understand speech. So you can take these models and fine tune them for your own purposes. And then there's other tools too. So if, say, you're working on a team and you're happy with your Docker container or your model, you can have a shared online space where you post all this information so that your team can grab it. And then there's other spiffy tools in it too, like there's some security checks and scanning that you can go through it, or you can do access controls. Hopefully make your life a lot easier. So as mentioned before, Docker is really powerful because it's portable. You can learn it locally and then deploy on the cloud. And the containers that NVIDIA has available, I know the engineers put a lot of love into it because they're going to be they fine-tune these containers so that it works really, really well with NVIDIA hardware. So if you have a GPU, an NVIDIA GPU, I highly recommend using the NVIDIA containers because the engineers will try and optimize TensorFlow or PyTorch or whatever framework that you're trying to use for your hardware. So you don't have to worry about it. Like, I don't know about you guys, but for me, the hardest part about being a data scientist, like, yeah, the algorithms and the math, they can be really tricky sometimes, but setting up the production environment is a lot of hard work. So you can kind of take advantage of other people's hard work here. So hopefully, because the NVIDIA containers are very well tuned to the hardware that they're going to be running on, the performance is going to be just so much faster too. And then there's other things that are on the NVIDIA GPU cloud. We have these AI toolkits and SDKs. One of the ones that I learned recently is a service called Triton that allows you to take your model, whether you built it in TensorFlow or PyTorch, or there's other types of formats too, like there's one called Onyx. So no matter what your machine learning model structure is, it will turn it into a web server for you so that people can ping your web server with a JSON request and you can build it into a website, which is pretty cool. So the other technology that might be useful to know is once you've mastered Docker, the thing that people use to push it into a production environment is called Kubernetes. So once you're familiar with how Docker works, you can use Kubernetes to kind of simulate a production environment locally on your machine and then be able to, once it works there, deploy it to a cloud. And as mentioned before, you can go ahead and post your Docker containers and your workflows into a private registry so you can share with your team. So I think that's mostly it. If we want to talk about what's next, I have a bunch of links here that are available for you. So you can come learn with this at DLI, or you can go ahead and check out the NVIDIA Cloud catalog and just go around and play with it. Or you can go ahead and join our community and talk to us. Like I mentioned before, NVIDIA gets like a huge sense of pride when we hear about the cool things that you all do. So definitely tell us about it. So I think that's it in terms of slides.